Hey everyone, I'm going to be talking today about motion in VR. So in my previous VR video, I was doing a little bit with the HTC Vive, and we were using the Vive input utility in SteamVR. And we're still doing the same thing in Unity, except we're going to go into a little bit more detail about how motion actually works. So a couple of things to keep in mind before we get started. We are dealing with actual people when we think about VR. It's not 100% virtual. The people are real, and we have to consider their physiological needs. For example, people don't like feeling dizzy. They don't like getting motion sickness. They don't like, if you've ever been car sick, then you know just how bad it really is. Imagine being car sick, but there's no car and there's no motion involved, and you just can't get it to stop. If you cause motion sickness for somebody who's using a VR headset, it can be a lasting effect, and it's really something that you don't want to take too lightly. If you give them motion sickness, it can cause them a lot of stress. So when we're thinking about motion, we have to kind of work past that and apply best practices and experiment and do what works. If you're trying something out for the first time, it might be a good idea to try it in a seated position, just in case things go wrong. Have somebody else there to spot you, literally to spot you, because you might lose balance and you might start to fall over and stuff like that. But let's get started. So with the Vive input utility, obviously you can teleport really easily. So you just have to throw a teleportable tag onto any kind of floor or surface that you want to be able to teleport to. So I'm just going to try that real quick and show you what it looks like. I am in a seated position with just one base station hooked up right now, so I'm not going to have the best tracking, but we'll get this to start. Oh, it looks like it should have started. There we go. So now I can see things, and I can just point my, controller wherever I want. I don't know if you guys can see that. Pointing my controller where I want, and it'll let me teleport if I want. Real easy. I don't have to write any code, so this is probably the easiest way to implement motion. It has relatively little motion sickness. The person's not going to feel it, to be honest. Another thing that you can do really easily and really quickly is just let them walk around. If you make your experience in such a small scale that they can actually walk from point A to point B, then that is, of course, going to make things a lot easier on them physiologically, because they won't have to worry about motion sickness at all. They're going to be the ones who are initiating the motion, and their body will feel the acceleration. The mismatch really happens whenever there is acceleration and the body doesn't feel acceleration. So you have to be careful about that. So what we're going to do now is we're going to get some locomotion involved. Actually, before we even start coding, what I want to show you is just which parts of the scene need to move for motion to happen. So right now, if I go to my hierarchy, I can look at these different pieces of the prefab. I'm using the Vive rig prefab in the HTC, the SteamVR plugin. So if I go to SteamVR, it has the prefabs, and then I'm using the Vive rig, which is one of them. I thought it was in SteamVR. Did it move somewhere? Oh, it might be in HTC prefabs. Yeah, it was in the HTC prefab. Anyway, so if I click on the Vive rig, and if I move its transform property, you'll notice right away that the headset is moving, and I can rotate the headset in different directions, and it's still moving in a global, on the global axis. So the transform of the Vive rig definitely operates as an offset for the person, and this is really the target that you should be going for. And the reason for that is if I try to move the camera, then what'll happen is even if I change the position, it's just not going to change. Let me go ahead and set the Y position to 20. Notice how it goes instantly back to its original spot. So the camera, we can't set that position because it's constantly being set. The same goes for the controllers. You cannot set the position of the controllers, or if you have any trackers, you can't set the positions of those trackers. But what we can move is the Vive rig itself. So you kind of have to imagine that there's some kind of virtual boundary which your Vive rig contains, and that is essentially the kind of collider that you'd want it to have. You got to be careful though about adding colliders. because if you do add, let's say, a box collider to your Vive rig, and then if I make this like size 5, 5, 5, then you know, see how I just knocked that thing away and I wasn't really there. And then like if I move it like that, you know, I don't know, maybe I'll knock it into the sphere. I don't think the sphere has that same kind of, it's not having that issue. Anyway, you can cause some problems by giving that a collider and just leaving it as a collider. Maybe it's better to make it as a trigger. Oh, there we go. So there's some interaction with the sphere. It might be better to leave it as a trigger. Like you wouldn't want this to run into the plane and give you issues. I don't know. It can just be weird. So what we're going to do is we're not really going to add a collider, but we're going to deal with just some motion here. Now keep in mind, with the Vive rig at 000, my camera is still located off the ground. My controller is still located off the ground. Right now the camera is sitting on my desk, so it is indeed off the ground. And the controller is also sitting on my desk, a little bit off to the side. So again, that one is also off to the ground. It's off of the ground, I should say. So we're going to be moving the Vive rig's transform, plain and simple. Now, if we go into a script, so let's go into the assets folder, and let's just create a simple C# script, move with Locomotion. This style of movement we're going to implement is called Locomotion. What we want to do is we want to change the transform of the Vive rig in very small increments such that it feels like we're moving at a constant speed. Locomotion can cause motion sickness very easily. So this is something you really have to be careful of when you're testing it, and then you have to make sure that you're not like going to get a bunch of people motion sickness the first time they try your VR app and then never come back to your studio again for any other games. So when we do our Locomotion, we're going to have to do a couple of things to prevent motion sickness. So if I go back into Unity and I check out my prefab and look for all the different things that are here, just a moment. You'll notice right now there's this camera, and then when I press play, it changes. So if you just wait just a moment, notice how it becomes a camera eye, but it's still the same one. So if you look in the scene view, it's still selected, even though I did technically select camera. It's still the same one, but now it just calls it eye. The camera is what we're going to be keeping track of in terms of its direction, because we're going to use the camera's transform forward in order to move our person to prevent motion sickness. So I'm going to need in my script a reference to the camera as well as a reference to the Vive rig so that we can kind of like edit both of these. So I'll go right up here at the top, and we're not going to do anything too fancy. We'll create a game object variable. And let me move my keyboard so I'm not spamming you guys with like super loud drum beats every time I press a key. So we'll call this one Vive rig, and then we'll do another game object camera. In fact, you know what? We don't even need to make them game objects. We can just make them transforms, because that's really what we're going to be accessing here. Maybe I shouldn't make it camera. Maybe I should make it like Vive camera eye. I don't know. Oops. And in the start function, what we want to do is we want to, do we need anything in the start function? No, I don't think so. Let's just do everything in update right now. Locomotion's real easy to do. You just have to make sure that you do it right. So the idea is we want the person to be able to use eventually they'll be able to use the input on their Vive controller to move forward. Right now I'm just going to do it on a keyboard real fast, just to show you the principle and like the fact that it works. So I'll do if input.getKeyDown, key code, and we'll use, you know what, let's just do axis, input.getAxis. Haven't done that in a while. And we'll use horizontal. Then we'll get something to happen if it's not equal to 0. Or maybe we want it to be able to get 0. I'm doing this wrong. It's been a while. We want to do float horizontal equals input.getAxis horizontal. There we go. Make sure you use the capitals. And then float vertical equals input.getAxis vertical. Again, make sure you use the capitals and spell vertical right. I've seen a lot of people spell that wrong. And now we want to create a vector 3, position equals, and our vector 3 position should really be the X and the Z are being set, not the Y. So I guess this shouldn't be like vertical. Maybe this should be forward. I'll make it just forward W so I don't forget. No, forward. Okay, whatever. We'll use forward offset. How about that? And horizontal offset. We'll be good programmers. New vector 3, position 0, forward offset. Oh, not position, sorry, horizontal offset. I'm out of it right now. All right, and then real simple, we'll just set our transform position of our Vive rig. I guess the most basic way to do it would be to set, I'll show you that one. That one really induces motion sickness. So Vive rig dot position equals position. We'll do it like that real fast. So we have our script and we want to throw this onto our Vive rig. Sure, no big deal. And then just take this, put it in the Vive rig, choose the camera, and then hit play. And we'll just do a little debugging, make sure that those are still accurate. Okay, so our camera's good, our Vive rig is good. If I, do this, I can move back or forward. So this is just a really quick thing. It's just setting our position based on the current value of getAxis. Now the problem is, if I press up, I go forward. If I press down, I go back. But when I start to look left, and then I press up, I still go forward in the world coordinates, and that's going to induce motion sickness right there, because they're not expecting that to happen. They're expecting to go forward. So what we're going to do now is change things a bit. Currently, our position is being set as the value. We're not adding anything. So this line is going to go away. We might reuse it. In fact, let's keep it there, but we're not going to set it to position. So right here, viverig.position plus equals position times time delta time. That's the first change we're going to make. That would make it so that we can move an infinite length. So I'll show you the difference right now. So now my character is looking forward, and I can move forward, and I can keep moving forward. So it almost gives me that feel like I'm walking. But if I press left and right, of course I'm going to go left and right. As soon as I look to the left, then pressing forward actually moves me to the right, and that's going to induce motion sickness right there. So avoid doing that. The last change that we need to make, this is kind of like the logical way of thinking through it, is all right, so now we're adding and it's cool, but it's not quite there yet. What do we need to do? Well, this vector 3 actually has all the data we need in it. We just have to reorganize and restructure the way that we're building it. So this horizontal offset is going to be our left-right movement, where negative represents left movement and positive represents right movement. And then this one is going to be our front-back movement, where positive represents front movement and negative represents back movement. So what we want to do is take the positive and negative values from this and then move in the direction the camera is facing, and then take the negative and positive values in this and then transform based on the direction the camera is facing. So let's see if we can get that set up. Hopefully it'll work. So we're going to delete this line now. We don't need that anymore. And this one, we can possibly keep that. I don't know. We'll find out. So we need to save some kind of vector 3 I forward. And this is going to be Vive camera I dot forward. So this is our starting point. Now in I forward, we really don't want a person to be moving up and down in the Y direction. So we should say I forward equals new vector 3, or maybe we can do this. I forward dot Y equals 0. Can we? Yeah, I think we can do that. All right. Let us now start moving if they're pressing any input. Let's get another vector 3. I right. Vive camera I dot right. And we'll do I right dot y equals 0. So again, we don't want to be moving up and down, otherwise our person's going to be floating and flying. Maybe you want that for your app. If you want them to be able to fly, then just leave the y as it is. Don't put this line right here or this line right there. But if you don't want them to fly, then make sure you set the y value to 0. So now we have the forward direction and we have the right direction, and we need to create some kind of vector 3 using that information. So we're going to create a vector 3 position equals new vector 3. And what we're going to do is, maybe we're not going to use new vector 3. We're going to use I forward times forward offset plus I right times horizontal offset. And then we'll do position equals position dot normalized. Otherwise, we'll get some weird like speed changes depending on if we're pressing both keys or one key at the same time. And at this point, we have our position, and so things are going to work a little bit differently. So I'll go ahead and save, and I want to put a few more things in the scene really quickly just to show you that everything is in fact working. So I'm just going to Shift D. Oops, I did not mean to do that. Let's Control D, I think. There we go. And just move a sphere over here, and then Control D and move one over here. I'm just making these like reference points so that we can see different parts of the plane as I move the camera around. So I've got my camera right here. I'm looking relatively forward. If I press, let's look to the left, look to the right. Okay, so this is forward. If I press up, I'm going forward. Press back, I go back. Press left, I go left. Press right, I go right. All right, so now I'm going to look to the left, and I'm going to press forward and watch what happens. So I'm now going in the direction I'm looking. This is going to induce a lot less motion sickness than if you were moving just in the global forward direction. So this is the best practice for locomotion in VR, is to let the person move in the direction where they are looking. Now you will notice it doesn't matter if I'm looking like up or down, I'm still going to be on the plane. Now because I'm like kind of swinging the headset around, sorry about that. It looks a little bit weird, but it's pretty straightforward here. Well, what just happened there? Oh, I think I covered too many sensors on the headset. So I don't know if you knew, but these are all sensors, and if you cover them, then things get wrong. But this is a pretty good locomotion system. It's going to avoid motion sickness. You're basically going to do the same thing except without keyboard inputs. Instead, we're going to use the inputs from our controllers. So if you'd like to figure out how to use the controllers to get your locomotion working, I'm going to do that in the next video. Thanks for watching. See you guys soon.